Okay, so time is up. We are the LP1 working group. We have 15 minutes, so we will ask you to present within your 5 or 10 allocated minutes. So we won't have time to make huge discussions as we normally do, but at least we'll be able to do a status of the current work. So please keep in mind that this is an IETF meeting, so all the best practice for the IETF apply. In particular, be courteous, try to speak slow enough for people to understand you, and obviously there is the IPR thing. So if what you're introducing has IPR on it and you're aware of that IPR, please let us know or tell the chairs after the meeting or tell the mailing list. This is going through Mitico. The minutes are captured through Kodi MD, so they are captured natively in MD. So minutes are taken, your presence is recorded automatically by the Mitico. So that's why you have to log in with your data tracker, and you can only log once on each individual session. And the meeting will be recorded and probably played on YouTube. So be courteous even more. So we thank Dominique for taking the minutes, and Dominique told us there were already 7 people helping on the notes. So that's really cool. Blah, blah, blah. So the material is logged as usual on the IETF site. And with this, let's go straight to the agenda. We don't have much time. So we'll present a brief status of the draft. And then it's going to be 10 minutes for Juan Carlos on the Sigfox draft, 10 minutes for Olivier on the LoRaWAN draft. Then Anna will tell us about SHIC over NB-IoT. And then Laurent will tell us about the Yang data model. And Anna will give us the status of the ASG review for the co-op static context header compression draft. So workgroup status, the milestones have not changed. So there we go. And it's a little bit small. I don't know if you can see it, but basically what this tells us is there is only one discuss left on the static context for co-op, the context compression for co-op, and that we have named a shepherd for the LoRaWAN document. We don't have much news about the OAM draft. So Dominique, if you want to just tell us a word about that. And then the SHIC over PPP draft was transferred to Interia, so that's why it doesn't show anymore. So Dominique, do you have news about the OAM draft?
It's still there, but no progress. Sorry.
Okay, but it's still there. You plan to move it forward. So I will be moving the slides for people, but if you want to present from your screen, you can also do that. Just let me know if you prefer to present. Otherwise, I will just be moving the slides. And with this, we start with Juan Carlos.
So, hi everyone. Can you hear me, Pascal?
Yes, I can hear you. I just pressed the wrong button. So let me come back to the right button.
All right. There you go. Okay, so perfect. So hello everyone, Juan Carlos Suniga, and I'm going to present a quick update on the SHIC over Sigfox. I'm putting my video just in case. It's up to the chairs if you want to upload it or not, approve or not. So the updates quickly on the hackathon. We had some plans to do some interoperability, but of course we're still having issues with the COVID confinement. So what we've been doing is some offline coding between the University of Chile and the University of Catalonia, the Polytechnic of Catalonia. And this is mainly focusing on the ACK on error and the no-ACK modes. The idea is to replicate the scenarios and then start moving back and forth, ideally evolving the current implementation of the PySHIC from UChile to other modes like NOAC, window, downlink, etc. Regarding the drafts, we have the latest updates for 2 and 3 combined here. So more details on the ACK on error, data fragmentation, and integrity mode. We added and updated the references and terminology. That's already from revision 2. The usage of sequence number from Sigfox, as we described before, to optimize the retransmissions, especially around the all-one fragment. And then we added a recommendation for NOAC usage, which I will explain in a further slide. We can move on to the next, please. So the testing network architecture doesn't change. We're still using the 5-SHIC software on the device, right now relying on a MicroPython running on a PyCom low Pi 4 device, connecting to the Sigfox network, and the functions on the platform is based on a cloud-native implementation, in this case running on Google Cloud. Next slide, please. So the NOAC is the one that I mentioned before. We added this recommendation to use the FCN to indicate the packet's size. And if you remember, we had that discussion at the moment when we were drafting RFC 8724. We actually requested recommendation of FCN. Originally, we were planning to use the FCN only as a binary number to indicate either the middle transmission or the end of the transmission of a NOAC packet, but we suggested recommending the use of FCN to indicate the size of the packet. So that's what we are adding here. What we say is that this, in combination with the Sigfox sequence number, will allow implicitly indicating the expected number of fragments and or the size of the packet that will be received. So of course, there's no acknowledgement, there's no data integrity in case there's a fragment missing. Too bad, we lose it, but at least the network will get an indication of the size of the packet and the integrity of the packet, even though it cannot recover from losses. So next slide, please. By the way, we are planning to implement this and test it in the next version of the PySHIC. So as next steps, again, interoperability test, ideally with PySHIC and other implementations. We had planned that for Vancouver, of course, didn't happen. Madrid didn't happen. So we don't know about Bangkok. Right now, it's a question mark. I would say a big question mark. So we need to be creative if we want to do some interoperability tests this year, I guess. Otherwise, the offline implementation is still going and in a very good shape. And the idea is to continue the fine-tuning of timers, shift header fields, etc., to progress the draft. Are there any questions?
Yes, Laurent. For the test, we are now running, or we are trying to run an OpenSHIC core on server, so it can be a way to test interoperability.
Okay, yeah, that's good. So is this, well, we can talk offline, but is this available?
Almost. Almost.
Okay.
It's something we have done during the hackathon.
Okay, that's very nice, because definitely the time difference has been an issue also on our side. So we can talk about the details, but thanks for letting us know, Laurent.
I granted him, but he went away at the time I granted him the queue, so I don't know. Laurent, can you go away, or do you want me to just remove you, or do you want to speak more?
I want to leave.
Just press the microphone on the right.
There you go. Okay. So
Ivo is there. Let me give him the grant.
Okay. Ivo, no question. Okay. So thank you very much.
It didn't work. Ivo, can you try again? When I grant you, it seems that you go away. So I say yes, and you disappear. That's interesting.
Okay. So is there a question from Ivo?
Maybe you can type your question, Ivo.
Yes, he's typing. We have a minute, so if he types very fast, I can answer.
I don't know why. So Laurent, it worked. I just granted him, and it worked.
I noticed with Mitico that when you log in and you choose the mic and stuff, you really have to make the right choice. Otherwise, you run in trouble, and there's no way to...
Ivo, can you press the right button? Just don't place yourself on the queue. Just speak. Use the right button, not the button with the hand. The button with the square. Just press that one.
Okay, so I see the question is, does the use of Sigfox sequence number means you cannot interleave? No, in fact, the Sigfox sequence number is generic. It's not per session. So we need to be a little creative there and have a generic or how can I say, a counter that is that spans over multiple sessions. But as long as we keep track of that counter, we can use the same sequence number independently of the number of sessions. So the answer is yes, we can interleave even with this functionality. Thank you. All right.
Many thanks. And
thanks a lot.
yeah, I guess we need to move on because we have very tight schedule.
Okay.
So thank you, Juan Carlos. And Olivier, can you show up? I don't see you on the queue. Yes.
Hey,
okay, great.
Do you hear me?
Yes, we do.
Perfect. So hello everyone. I will introduce the updates on the check over LoRaWAN. So we will see the changes since last IETF virtual meeting and some words about the next step. If you can go to the next slide, please. So we did a last call on draft 07. Thanks to all reviewers. We had a lot of good comments we integrated in draft 8 that we published about 2 weeks ago. So now we'll see the changes in that draft. So we added the some example for the uplink all one with the last time, which was not the case for more clarity. We fixed the ID example. There was a small issue in the algorithm use. We use the RFC 8376 terminology, so there is no more end device, but it's devices and so on and so on. So every draft should be consistent and easy to understand on all technologies. We installed bitmap possibility in the check acknowledge example. We had some more examples, fixed some needs and typos. And we spent a lot of time specifying the retransmission timer. We already discussed that a lot in the interim meeting. There was no retransmission timer, and now there is retransmission timer, and they are optimized for LoRaWAN case. And they also take into account the network server that cannot manage the queues. We clarified the downlink opportunity and other fragment parameters, thanks to the reviewer's comments that it was not really clear. And we should have described all the RFC 8724 and XD parameters, so we should be good to go. So next steps, we published the draft 8 2 weeks ago. We did not receive any comment yet. I don't know if it's because you guys are missing time or everything is okay for you. So I don't know if we should end the last call somewhere in the future. It's my first document in IETF, so maybe the chairs can help us here.
Last call is finished. It's just that we were solving the comments that were given during the last call. Now, clearly, if one comment was given after the end of the last call, it was an interesting comment, we would still process that. But yes, officially following the process, we are done with the last call. We are just solving the issues, and once we are happy that the issues are solved, then ready to go, right? So it seems to me that version 8 could be pushed for the IETF review now. So I guess the first thing which will happen is the Shepherd does the Shepherd write-up. I guess, Dominique, you've started that, and presses the button. You're used to it, Dominique? If not, just I can work with you to see what button exactly needs to be pushed, but it's a publication request button on the data tracker. And once this is done, then normally the Eric, and Eric, if you're there, will show up and they ask for the IoT, I guess the IoT directorate to give us a review. So Dominique, so you come and then go. You're welcome.
Okay, I'll do that. I haven't done that before, I think, but I'll check with you.
Okay, we can have a quick call after this meeting or when you like, and I will show you exactly, because there are several old ways which don't work well, and there is the official way. So, okay. So with this, we'll move to the next presentation, which is.
I have a last question for all the reviewers who opened issues or comment. If you think that your comment has not been addressed as you want, please tell me as soon as you can.
Please, yes, do.
And if you think that all your comments have been resolved, please say it too. It will help.
Yes, and by default, we'll consider they are. So please send, if and very quickly if you think something is missing. And now with this, the ball is yours. Just let me to move through the slides.
Okay. Can you hear me? Okay, I will press. Yeah, okay, thank you. Okay, this draft gives a recommendation for using CHIC on the 3GPP architecture. The complete work must be done at sea. As you can see in this slide, the 3GPP architecture is more complex than the one we have used in the RFC 8376. Here we have the user equipment and the application server, but we can have different network gateways. Alex, you have a question?
Yes, no, I just wanted to say that we are a little bit ahead of time. So initially you had 5 minutes for a presentation. I think that you can do 10 minutes. So it's okay. We have some time.
Okay.
Thanks to the previous presenters.
Thank you. So this is the first time we present this draft completely. And today we have also finished the fragmentation configuration and parameters. Next slide, please. So this one. So as I was telling, the architecture is more complex, and we divide the work in different use cases. And I present each use case because it will be different for the network gateway. So the first use case is the one where device is the user equipment and the network gateway is the node B. So we are in the radio link. Here we are using the PDCP layer as the 3GPP defined all the header compression in this layer as ROC or Van Jacobson. So here we can put CHIC compression. In this configuration, we don't need fragmentation because RLC layer makes segmentation. So we don't need CHIC fragmentation. So for the rule ID, we can get dynamically a number, and it could be up to 9 bits. Next slide, please. The second use case is when the network gateway is the edge router of the radio core network. Here, then we have CHIC in the device and CHIC in the router CSGN. We can use compression and fragmentation in this case. For compression, again, rule ID can be up to 9 bits. For fragmentation, we have a very little packets. So we will see at the end the configuration. In this use case also, we will use, or we can use, control link that has a transport block from 2 bytes to 125 bytes. And we can also have a data link where we can have 1,300 bytes. So we have very big bandwidth and very small bandwidth. Next slide, please. The third use case is when we can use the application server as the network gateway. In this case, the NB-IoT network is clear, so the device manage the rule ID with the application server. In this case, we can use compression and fragmentation. Here we have some applications where non-IP packets, very big non-IP packets, for example, and firmware update can be sent between the device or between the application server and the device. So we manage how to make this configuration for this type of service. Yes, Juan Carlos.
Well, yeah, you finished with the use cases? I just wanted to make sure.
Yeah. Yes.
All right. So, 2 questions. The first one, on the number 2, I guess you would need to transfer the context to the visited PLM. In this case, you need some sort of coordination between the device owner and the roaming network. That seems a little complicated, no?
No, it's already done for ROC. So it's already done for ROC. We are going to do the same thing. It's in the home network will send the HLR for the home network, send the information of the context to the actual network, or I don't know how to say it, but virtual network, the one you are now. So the two HLR will manage to send the information one to the other. It's already done for ROC. So we plan to use the same thing to manage the rules ID or the rules to one home network to the other.
Okay, that's nice. Probably good to explain, because at least to me it wasn't obvious. But if there's a solution, that will be interesting to know. And the second question is, you didn't consider over the top SHIC, like end-to-end, like running transparently over the 3GPP network, in the sense that the 3GPP network could be completely non-aware of the SHIC being used on top of NB-IoT.
Yes, is the last, is the third use case, I think. The next slide. Is this one? So I have SHIC on the top of the network. So it's the 3GPP network is clear. I cannot do anything inside. And I have to manage the rules and the compression context and everything from the device to the application server. Is that your question? Yeah.
Yeah, that was probably I misunderstood the slide, but yeah, that was my.
Yeah, and here again we have an SCEF. It's a new device in the NB-IoT network, which manage this kind of links to clearly pass the context.
Okay. Thank you.
Okay, next slide, please. So for fragmentation configuration, we want to use the ACK on error mode. And as I explained before, the transfer block is between 16 bits to 1000 bits, and they vary for each 16 bits. So we have relative fixed transfer blocks where we can put header or define a header multiple of 4 bits. So we try to see where was the best configuration. Yes.
Well, I mean, I can't parse what you just said. 16 bits to 1000 bits, varying by 16 bits. What does that? Can you reword that?
Yeah, because you can have transfer blocks of 2 bytes, 4 bytes, 6 bytes, 8 bytes. So each time you get a transfer block, it could be a multiple of 6 bits, 16 bits.
Sorry.
The transfer block sizes are defined as multiple of 16 bits. So it starts at 16 bits. This is the little transfer block size. And then it goes to 32, and then goes to 64, and so forth. So I cannot get in the middle 24 or 38. The transfer blocks varies or change in size every 16 bits. I don't know if you understand. The size of the transfer blocks is a multiple of 16 bits.
I guess Anna just said transfer block range from 16 to 1000 with an increment of 16 bits.
Yes, well, thank you.
Yeah, and 1000 is not a multiple, so that's confusing.
Yes, it's 125 bytes.
Anyway.
Okay. So in this configuration, we try to get the best header size for these transfer blocks, and we decide to make two configurations, one of 8 bits and one for 16 bits. The one for 8 bits perhaps could be used for the transfer blocks less than 300 bits, with the roll ID of 3 bits, the tag of 1 bit, and FCN of 3 bits, and the window of 1 bit. We have to consider that in the 3G network we can have burst errors where we can lost all the window. So that's why we need to identify at least 2 windows. For the 16 bits configuration, so we give more opportunity to number different windows, to have different packets, because we can have interleave packets, and we in the study we made, we realized that the worst case we can have is to lose 1 packet in each window. When I lose 1 packet in each window is when I get the worst performance. And next slide, please. So for the timers, we investigate the size of the timers in the 3G network, and we find that for IoT devices, the range goes from 1 hour to 10 hours. So we decide to put the same level, the inactivity timer and the retransmission timer. So next slide, please. So that's the end. If you have questions, more questions. We would like to have a reviewers for this work to see what do you think of what we have done.
So in particular, I would really appreciate that people who worked on the LoRaWAN specifications, who got used to this kind of document, could see if there is anything, any section, any kind of text that is globally missing in this document, or if we have the same coverage as we have with LoRaWAN. So Olivier and others, I mean, Ivo, if you could have a look, that would really, really be nice. Thank you in advance. And Anna, thank you for being in time. Actually, we're still ahead of time by something like 2 minutes. So I guess Laurent, the ball is yours. Alexander,
just one point. I think Ivalo was writing a message. Okay, so he says that he'll look at it, and to Olivier as well for asking for the deadline. I wouldn't expect, Olivier, that we have any hard deadline. So if you can do that in the following weeks or a month, that would be really great to have first input.
Yes, I mean, if you could have a look before now and September 1st. I mean, some of us are being in vacation for several weeks. I don't know, not me, but so enjoy your vacation, do your stuff. But you know, when things start over in September, it would be nice that if you could have this log.
Okay.
Though, if you want to jump to the mic, just press the button on the right, the one with the microphone and the square, or a triangle. And just press that one and come immediately. Seems to be something weird on Ivo's side.
Hey,
Yes, we
can
can hear you now.
So I think I just needed to change the browser, and now it's so good. I will file a ticket. But yeah, nothing more to add.
Okay, Laurent, ball is yours. Just let me know to move on the slides.
Okay, so that's my time, I think. Yes, so I'm going to talk about the data model, so the last version. So this now we have something that is quite stable, and you can have access to it on the LP1 repository on GitHub. And so you have the chic YANG file with the date. This way we can see which one we talk about. So what is new in this YANG document is that we have merged, just before we had one YANG file for the ID and another one for the rules, and now both of them have been merged in a single file. We added also some identifier for chic parameters, mostly all of them. We have also defined the fragmentation parameter. We add also description to explain what are the meaning of each field. And also we work a lot the mandatory optional fields in the YANG models to optimize things. So just to give statistics, it's about 123 elements. So 88 of them are IDs, and the rest is the rules I use for the rule definition. So next slide, please. So to give you an idea of how we define identity ref for all the elements. So you see the first line, we define a base type, which say, for example, this will be used for RCS algorithm. And so it's an identity. Then we define each identity for all the RCS algorithm that derive from this base type. And then we define a type def that will be used in the YANG model. So next slide. So this leads to the definition of different types. One is for the field ID, one is for the length, which is an union of a number and identity ref. We have one for direction indicator, one for matching operator, compression, decompression action, etc., etc. You have the list here. So what we try to do is to take all the fields, for example, for a field ID, all the fields that can exist, and even in the future, we include here fields that can be taken from the AOM draft, so concerning IPv6. And next slide. And we also add things regarding co-op options. Okay. Next slide. So here is the definition of rules. So definition of rules is it's a list of rules that are identified by rule ID and a rule length. We also add a rule version that can be used for management, but this is a value that is not defined in the chic RFC. And then we have two nature of rules. One is fragmentation and the other one is compression. So we can focus on fragmentation first. So each rule has a direction that can be up or down. B, of course, is forbidden and is used to know the direction of rules. So this is a mandatory element. Then we have the DTAG size and window size that are optional element that can be used in icon error or ACL ways, but are not used, for example, in NOAC. And FCN is a mandatory element because we find it on all the rules. Then we have the RCS algorithm, as we saw before. and the max window size that is normally computed from the FCN size. So it's 2 power FCN size minus 2, but we can reduce this value, and so in that case, it's the maximum window size that is set. We have retransmission timer. So this is a mandatory timer, so it's a value between 1 second and the maximum we can do with 64 word, bit or longer word. And we have inactivity timer that can be, as discussed with LoRaWAN, optional. So in that case, we can put value 0. After that, we have the macaque request. And yeah.
Just curious, but when we say that, how do we indicate the unit of time, for instance, for a transmission timer? I mean, do we base it on the spec, so people have to know this and then the spec, or is there a way
what I understood is that it's in the description of the field that you say that the unit is seconds.
Okay.
Maybe we can derive another type that will say second, but I don't know if it's quite useful. And then
I think at that point, once we decide that, okay, well, that's the way to, when we are happy with the model and the data model is pretty stable, we can ask for the young data doctors to review it, and they will, they can indicate if there is a better type to put here, or just leave it as it is and with a comment.
Then for the last field, we have a fragmentation mode type that can be no hack, hack on error, hack always. And for each of them, we can define parameters. And right now, we just define parameters for hack on error. And these are questions that for interoperability issues. So for example, do we put tiles in all one? So it can be yes or no, or we can say, since the protocol allows it, that the sender can choose if he uses it or not. And we have the hack behavior. So the hack behavior is when you send an acknowledgement, it can be after all 0, after all 1, or given by the physical layer at any time it's possible. So next slide is for the compression. So the compression is not new, so I will not go into much details. The only thing that I think it has been done just before, it's that target value is a union of binary and string. So we can easily carry any size of binary information or string, for example, like in URI path in CoAP. And you have all the parameters and the rules. So next slide. So here, I'm quite happy with the rule now, or the young model now. It's something stable. So of course we have to enrich it and review wording, because description of field is very important to avoid ambiguity. And we have also, as Alex said, to check the model with young experts. So for me, it's okay. So we can do this work before doing a last call, but last call may be a way also to push and to do the work. So I have the chair to decide. And by the way, I received some comments from Ivo this morning that are quite interesting. We have, and thank you for that. It's I will discuss of them tomorrow, but I don't think it's big changes.
Laurent, I would be happy to launch the last call. It's just that it's summer, and I see that all the people joined the meeting, but maybe some people will take vacation. So even if we launch the last call now, we will have to make it an extended period, because people will take...
we can. So we can do it in September, as you.
Yeah. So if we do it in September, then why don't we try to get some young doctor review in the meantime?
Yeah.
Because if there is a change, then we'll review after the change. It's kind of nicer for the reviewer.
I would probably also so that's a question or maybe an observation that it might be good to wait for the SHIC the co-op over SHIC draft to be to be accepted by the ISG, because I don't expect there to be any changes on the data model. But just to be on the safe side, to know that okay, well, everything that is in the SHIC co-op over SHIC draft can be expressed with the Yang data model.
Right, so that's consistent, right? I mean, if we could get the SHIC doctor between now and September, and early September we would launch the last car, that would be nice. Yes, that's kind of a plan. So I don't know who launches this SHIC doctor thing. Is it something that you need the chair to act on, or I just don't know?
I think it's the chair.
Yeah, it's the Yang doctors. Not
yeah,
yet the
SHIC
doctors.
doctor.
Yes.
Who's going to be the SHIC doctor?
But that would be
I volunteer.
Sorry.
Yes. So actually, Pascal, we need to find this out, and probably also with the help of Eric. At some point, it was
Eric is here.
Yes.
Yeah, so basically, it's usually you ask for a review. That's pretty much the same thing as you ask for a review by Indirectorate or IoT Directorate. You ask a review by Yang doctors. I can do it. I'm not sure whether the chairs can do it, but in worst case, you can send an email, right? And people will do it.
So Eric, take it as the unofficial request. We'll make the official request by email, but be prepared. So the plan is...
No problem.
Okay.
I don't take vacation in August, right? I'm French speaking, but I don't live in France. Sorry.
Okay, thank you.
So Juan Carlos says that the doctors are busy these days, so probably maybe they're all French. So we should probably in terms of timing, if we aim for review in September, that would be really good. Of course, we can. If you have that before that, then that would be really good.
You can ask now and see when it comes.
Sure.
Okay, so we need to move to the...
Yeah, just one point. And we have also to synchronize maybe with CoreConf to see if how we can process.
Okay, does that impact this document?
I don't think we need to. So Laurent, probably you're right that it would be really amazing if we have both documents at the same time or synchronized. I don't think that we have to put a dependency on CoreConf. So the document is self-contained as it is. It works really well. It works also with CoreConf. But I don't think we have to put any dependency, because it may take some time for CoreConf, and let's ship this one, and we'll push on CoreConf side as well. So.
It seems that in the aggregated side, slides I had twice the same content for some reason. Okay, Annabelle is yours.
Okay, now I will present the status of the co-op static header compression. So next slide, please. The status is that we have only one discus to solve. The other two discus have been solved for the last version. Thank you to all the reviewers, all the inputs, and the discussion we have about this draft. Next slide, please. So what has been modified from version 13 to version 15 is we have divided in section 2, the first figure has been divided in 3 to better explain the different scenarios where we can use co-op and SHIC with co-op. This doesn't mean that we are going to define the architecture here. This only is showing where we can apply CHIC for co-op. Next slide, please. The second thing we have changed is in section 4. We have tried to eliminate the confusion there is about unidirectional and bidirectional fields. So the input was that the co-op header fields are not unidirectional or bidirectional, are always bidirectional. What we need to explain is that to make compression, a bidirectional field could be divided in two, depending on the direction and the target value. So when a field ID is bidirectional, but the target value change in each direction, to make the compression, we need to define it twice, one for each direction, up and down. And that's what we call unidirectional and bidirectional. So we eliminate all the unidirectional stuff, and we try to be clear about this way of compression. Here in the example, I put the jury path twice, one for up and one for down with two target values, with two different target values. Next slide, please. So next change is section 5, the options. One input was what happened with the new options? Are there? Can we also compress them or not? Is this out of the scope of the draft or not? So what we have done is to put a definition where any file that is defined as now the co-op options with type, length, and value format, DTLV format, could be compressed with CHIC, where the type will be the file ID, the length gives the file length of CHIC, and the value will be used as the target value. So this has been put in the introduction of section 5 to be used for all the options. And then we solve the options that are already out now. And the last change we have done is to improve section 9, security. Sorry, yes, thank you. Where we have clearly specifies the security of 8724 for LP1 and the 8613 for OSCORE, because there was a little mix. So we have clearly defined each security part for each use. We have added those attacks that can be cause an excessive resource consumption. We also clarify the way that perhaps she could help to avoid these attacks, because when we send the length, we are not sending the original header length, but the length of the compressed header. So this will be more difficult for an attacker to send a correct packet. And the last thing we have improved is we rewrite the part of the vector of the OSCORE part for the size, and because this implies to renew the key each time this size change. So next slide, please. So after this version 15, we send it again to the ISG, and we get the last discussion with Benjamin Kaduk, where, okay, the section 2, he said that it's very difficult to follow the division of the three figures, that we need to better explain what is the dashed and the dual lines, that we forgot to change the unidirectional and bidirectional in section 3.1. So we need to check again this part. And it's not very clear how we can, that we reflect the way to compress any option. So we need to rewrite or reflect this better. And he had a discussion about the security consideration, where he sent some inputs that we need to add to this section. Next slide, please. That's it. Thanks. Questions? Some questions?
No question. So we are exactly at the end of this meeting. So I believe we've done a lot, and in particular, Anna, on this code draft. A lot was done during this not this quarter, but yes, this quarter between IETFs. So thank you very much for the hard work. As you discover, going through the ASG is not the easiest part of the process to get RFC. But you had great reviews, and I do believe that the document is much better off now than it was. So big thanks to the ASGs for all those reviews, and to you for handling them. And with this, we are going to close this meeting. So any last thought for anyone? Okay, so I guess we are straight on the hour, and we'll thank you all very much for the hard work, and for those who take 2 months of vacation now, enjoy your vacations. And you all take care.
Yeah. And thanks to the minute takers. Thanks, Dominique, for leading the minute taking effort, and thanks everyone. And hope to see you all soon in person.
Okay. See you.
See you. Bye-bye.
See you. Bye.
Bye-bye.